Greetings and welcome, friends. Mr. Waddy here. We are talking 5.2 congruent polygons. We're going to be talking about their sameness in terms of angles and sizeness. It's going to be great, Alyssa. Just you wait. I'm telling you. So think back about geometric figures that are congruent if and only if a rigid motion or composition of rigid motions maps one of the figures onto the other. A rigid motion maps each part of the figure to a corresponding part. So like they're in the same location with respect to the figure. All right, because rigid motion preserves length and angle measure, corresponding parts of congruent figures are congruent. This right here, corresponding parts of congruent figures are congruent. C, P, C, no, man, almost got it. That's like CP, CF, C. Usually, we'll end up having corresponding parts of congruent triangles are congruent, but today we're just talking about figures. So that's really just about any old shape that you can think of. Or just remember the words and then the acronym will show up. It'll be great. Don't worry. In congruent polygons, this means that the corresponding sides and the corresponding angles are congruent. So look at this. That means angle A is congruent to angle D. That means B is congruent to E, C is to F. Side lengths also, corresponding parts are congruent. It makes sense, right? If the big fig is congruent, then all of its little pieces will be congruent to one another. Let's see. Repeat that. I'm gonna skip all that. Let's just jump right into example 1. Oh man, what's with like this ghost effect? I hate the ghosting. I know, and I ain't afraid of no ghosts. Let's see, example 1. You can see the ghosting right here, though. Do you guys see that? Yeah, like when like the image from my previous screenshot shows up in the new one. That's not helpful. Example 1, identifying corresponding parts. Write a congruent statement for the triangles. All right, so triangle, ready, catch this. JKL is congruent to which triangle? All right, now the order that I wrote these has to match the order TSR. Ooh. Let's see, the double arc, yeah, T, I agree. And then let's see, K was the triple, so S, yep, I agree, and R. I like it, perfect. All right, and then identify all pairs of corresponding parts. So let's see, angle L is congruent to the who now? The angler. We've got angle J is congruent. Watch, I could look at the image and find it here and here, but as long as I named these correctly, Haley, we can actually find the congruent corresponding parts right in the name. Watch this. Angle J was in position 1, so that's going to be congruent to angle T. And similarly, angle K, looks like I'm missing, is going to be congruent. K was in the middle, so it's congruent to the middle over there, angle S, like so. And now watch this. Also for sides or whatever, JK, the segment, is congruent. JK was the first 2 letters, so it's going to be congruent to the first 2 letters there. Guys, this just like makes so much sense. Thank you, mathematicians, for making the sense. Let's see, KL is going to be congruent to the SR. And lastly, watch this, JL, the segment that combines the first and the last, will be congruent to the T and the R. Congruent to the TR, right? And I just did all of those based off of the name in the relationship for the congruent statement between those 2 triangles. Let's just verify one of them. Is JL congruent to TR? You better believe it. Oh, yes. Wonderful, wonderful, wonderful. Aren't you guys? You guys just love it. You guys just love it. Let's do example 2. Oh, guys, man. So let's see here. Using properties of congruent figures. In the diagram, this quadrilateral, it looks like just it's no particular type. DEFG is congruent to SPQR. Find the value of X. Here's an X right there, right, Lauren? Oh, there's another X right there. Now, wait a minute. What is going on? This one relates an angle, and this one relates a side length in feet. Yeah, degrees in feet. That's how I knew those units were not the same. All right, so QR is congruent to which side? Let's see, QR, FG, or GF. Yeah, I could see that. And if their segments are congruent, then their measures are equal. So 2x minus 4 is equal to 12. So I make that relationship, and now I solve, oh, good old algebra. It's just like a sock that I wore 2 days in a row. It's so comfortable to slip back into. But it's kind of like it's molded to your foot. Yeah. I found these socks on my bedroom floor. They were good enough this morning. There we go. X equals 8. There's a Waddy fact right there. Someone's going to timestamp that Waddy fact on this YouTube video. So let's see. And if I want to figure out this, I know this value of X, Haley. What does angle Q correspond to, Haley? Angle Q corresponds to which angle here? Angle F. So I'm going to suggest that 6y plus x is equal to 68. And also check this out. Ready? Right? I just did some substituting. So let's see. Let's solve this for y. By plugging in what I knew for x, I could then solve for the remaining variable. How wonderful is that? Oh, good old reliable math. And switch in the colors, dividing by the 6. I get y equals 10. And thankfully, they only asked us to find the value of x and y. They didn't do like the weird thing of like, but then tell us what this is equal to. Like, come on, I just want to tell you x and y. That's all I want to do. I don't want to tell you what one of those angle measures equals. Ooh, wow, this person's painting a room? Oh, man. This lady's like, painting a room. You were? All right, here we go. Also, when it comes to laundry and re-wearing clothes, don't wash your ties, friends. First year teaching mistake, destroys them. It just destroys them. So yeah, you like ties. I do re-iron my tie every time I wear it. I do wash my socks. Just sometimes I don't feel like binding them again. What else? Oh yeah, also when you wash your dress clothes, make sure you take your chapstick out of the pocket. It will destroy all of your dress clothes. Man, it's so sad. Earbuds. I actually, let's see. All right, Isaiah's caught up. That was the laundry advice minute. Here we go. Showing that figures are congruent. Okay, all right. You divide the wall into orange and blue sections among J, K. Oh yeah, that's yellow. We'll call it yellow. All right, so we divide the wall into 2 congruent sections along JK. All right, just kidding. Will the sections of the wall be the same size and shape? Explain. Okay. So from the diagram, I know that these angles, let's see, angle A is congruent to angle C. All right, those are corresponding. I know that angle D is congruent to angle B. All right. Can you guys make a claim regarding angle 2 and angle 3? How do you know? Excellent. Excellent. All right, there we go. Alternate interior angles theorem. Wait a minute. Did I know that these lines were parallel? Oh, because of 90 degrees. The line's perpendicular to a transversal theorem. That's a thing. Yeah, if these are both perpendicular to the same line, then they are parallel to each other. That makes sense. That's just good sense right there. And then how about this? Angle 1 is congruent to angle 4 with the y now. Why do you think that? Alternate interior angles theorem. That's right. Good stuff. Also, don't paint a room like this, guys. No. No. Yeah. Let's see. All right. Yeah. Huh. Okay. All right. So let's see. Angle 1 congruent to angle 4. Now notice I've just correlated 4 pairs of congruent angles. These are 4-sided figures. I assume they only have 4 angles. Let's talk about segments. Let's say AJ is congruent to CK. It's already labeled. That's given. Let's say KD, kill-death ratio, is congruent to JB. All right, yeah, that's given. Let's say that AD is congruent to CB. Did you say Chris Brown? Wait, you know CB? Wait, like the gym teacher, the health teacher, CB? Okay, never mind. All right. All right. Guys, I'm missing one pair of... Oh, man. Guys, I need one more pair of congruent sides. What do I do? Does anyone see it? I think JK is congruent to somebody. Guys, do you see this one? By the reflexive property of congruence. Anything is congruent to itself. Anything is congruent to itself. And therefore, I'm going to say AJKD is congruent to who now? Get the letters right. Who can get the letters right? C, K, JB. You got it. Nailed it. Good stuff. Good stuff. I mean, yes, yes, gentlemen. Yes, gentlemen. No, that's not quite. No, that's not quite as good. All right. Oh, guys, check this out. Theorem 5.3. Triangle congruence is reflexive, symmetric, and transitive. You guys knew that there was all these properties applied to equality. You knew that they applied, ladies, gentlemen, please. You knew that they applied in terms of congruence of angles and congruence of sides. But behold, it also applies for congruence of triangles. I know, Lauren, it's crazy sauce. I know. Yeah. So let's look at one more. All right, the third angles theorem. Guys, take a look, gather with me. Mentally focus at the screen. Verbally silence our mouths unless one of us are adding an appropriate comment or question. Here we go. Third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, the third angles are also congruent. Do you guys believe that?
Yeah.
Could you give, I know it says proof is example 19 on 244, but could someone give me like a breakdown just to like at least make me feel good about this in the meantime? Okay, so you're using some trisum in here. You're saying that all three of these add to 180, and all three of those add to 180, and there's only one number that could add with those first two that add to 180, and since those are congruent, by def of Kong, their measures are equal, then the remaining measure must be equal to this measure, and by def of Kong used in reverse, those angles are congruent. I think that makes sense. I was reading you loud and clear. Let's see. Oh man, it switched my screen. Okay. Oh wow, guys, I love this problem. This is like, I don't know, it reminds me of like origami or something, Malik. What do you think? All right. Horse legs. Okay. Didn't know. Find the measure, ladies and gentlemen. Find the measure of angle BDC. So gentlemen. BDC. This angle right here. Right there. Okay. Does anyone, anyone have any ideas? Okay, yeah. Josh. So you're saying that measure of angle ACD plus the 30 and the 45 is equal to 180? Do you guys agree? Let's see, so that's plus, what's that, 75 equals 180. And then what do I do to find that measure? Well, we added them together, like you said, eventually. And so I get 105 degrees. But which angle is 105? That's this angle. And then you're saying that the angle ACD is congruent to angle BDC because of the third angles theorem. Tat, 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 right? And then their measures are equal by def of Kong. I know like you guys probably see this proof coming a mile away, but I just want to make sure that you guys are used to some of these reasons. So that's def of Kong. And if their measures are equal, and this one's equal to that one, then by transitive property, the measure of angle BDC is equal to 105 degrees. And why is that? Transitive or substitution. But be careful, sometimes substitution is the only one that works. All right. Oh, wow, guys, I love it. Oh, my goodness. Guys, this is going to be our first. Ooh, can't wait. One last problem. Okay, I'll let you write it down. Oh, and then I think we might make it in time for a chicken story. My chicken stories have never before been recorded on the internet, and for my internet friends, I'm sorry, they will continue to never be recorded on the internet. Okay, just verifying, yes, that is still true. Okay. I've recorded a lot of my life on the internet, so I don't know. Who knows? Like, I'm probably at hundreds of hours. Well, I was waiting for someone to write this down. We were talking about chickens in the meantime. Maybe, yeah, between preaching and teaching and what else? Captain Wilderness. I also like we record like all our family videos on cell phones and then upload it privately, like as private unlisted videos on YouTube, and then nah, but I don't need to make money off my kids by posting them on the internet. Waddy waddy. Here we go. Oh, my gamer tag? No, I'm not sharing my gamer tag. 1.21 gigawatts? No, but watts would be spelled W-U-O-T-S or something like that. No, I don't think I did tell you. All right. Well, we're not going to... Anyways, proving that triangles are... I'm pretty sure I've... Oh, wow. Maybe I did. All right. I don't have a very good filter. Use the information. Guys, this is huge. We are going to spend so much more time proving triangles congruent. This is like our first time ever. I love it. I can't wait. All right. Right now, we are limited in our ability to prove things about congruence. But let's do this. Let's make a proof. All right, you guys are writing this down. Could you guys do this proof, do you think? All right. Don't worry about it. It's okay. I'll keep training you to be my math ninjas. Let's see. I'm going to say angle A. Josh, angle A is congruent to angle O. Guys, bad news bears. No one knows what I mean when I say angle A. Let's say angle CAD is congruent to angle ACB. Right, reason given. Let's say that angle CAB, or no, I'll do this one over here. So ACD. Yeah, we're just labeling our givens, you know. Whose angle ACD congruent to? That's CAB. The reason is given. Let's see. How about this? I'm gonna do a non-given statement. Angle D is congruent to angle B. Anyone know why? Third. Tat. Angle theorem. All right. Usually I go brap, like I'm just thinking about like, I don't know, like some, I don't know, P90 in like Call of Duty 4 or something, like brap, like, you know, just like, it's pretty amazing. Also, yeah, P90 is my favorite Call of Duty weapon. There you go. Hey, you agree to disagree in the comments below. Let's see, let's talk about some segments. AD is congruent. Are you guys getting good at writing congruent symbols yet? BC. Donald Trump equals. Hashtag Donald Trump equals. Hashtag make congruent symbols called Donald Trump equals again. Excellent. CD is congruent to AB. Given. Let's see, I'm going to say it. AC is congruent to CA. Anyone know why these are congruent? Oh, that's right. Reflexive. You guys got it. Reflexive property of congruence. All right. Anything is congruent to itself. And now behold, I'm going to say it. Triangle ACD is congruent to triangle CAB. The reason? All corresponding parts are congruent. It's just kind of like our definition. It was what did we hit earlier? Yeah, Willy Wonka. Where's my scroller here? All the way up here. That yeah, if the corresponding parts figures are congruent, then the figure is congruent. Guys, we just proved these triangles were congruent with some flavor in here. Look at this. We use this. We use one of these. Yeah. I think we're good. Well, thank you for watching, internet friends. I'm so excited about this chapter. Like, this is for real. Where's my mouse at? There's my mouse. Bye-bye.